Okay, and I think we're live with that. So today I have my third guest on. Hello, K Fury. Actually, I mean, I guess you go by your usual real name everywhere, right?
Yeah, that's true. I go by my name, which is Kristaps Balladis, many places, but my YouTube channel is K Theory.
Yeah, exactly. So this is K Fury. Actually, you're actually the first actual mathematician or PhD. Previously, I had like a philosopher inclined guy and really an engineer. So this is hopefully more like we will have some critical technical points to be made in this video, in this podcast. So before we get into what I have planned for you, which you don't know yet, can you say a little bit about yourself? Like, what do you do? What do you want to do? Where you want to get? How you feel about your current situation? Because this is a little bit of a theme in your on your YouTube channel, right? You're like
Yeah, yeah,
philosophizing a little bit about life as a mathematician. So please.
yeah, yeah. I mean, some part of those questions is actually a really big question. You could spend the entire time just yapping about how confused I am about some of those points. But yeah, I mean, currently I'm a PhD student in mathematics. I'm the end is in sight. I mean, my thesis is basically written. Like the main papers for it are basically written. I kind of just got to staple them together and then defend this winter probably. And so that's where I currently am. And YouTuber. I just this morning. Well, I don't know. Maybe it was last night, but I just crossed the 10K sub barrier. So yeah, and where I'm gonna go, I don't know. Like I've been applying the postdocs.
Yeah.
I just got my first postdoc rejection the other day, which I mean that was probably one of the less likely ones for me to make anyways, but I was also kind of like, oh damn, it would be cool if I got that one.
The Swedish one, right?
The Swedish one, yeah. Yeah, it would have been at the intersection of automorphic forms and proof assistance, and like that's pretty cool. It would have been a good excuse to pivot to proof assistance.
So actually, about that, is this at the moment fairly hyped, or is this just because I have intersections with machine learning, and that's why I just hear more about it? Like, how big is that now?
I mean, it's definitely it grows every year. It grows every year, and I think I think it's inevitable that proof assistance, like all of math, will be swallowed by this. Like I do dream of a future where all of math is just done in a proof assistant.
You dream of it, so you are pro.
Yeah. I mean, as like supposing that we get it to a place where our libraries are totally up to speed with modern knowledge, and that the sort of user end of things becomes like really no more difficult than just writing a theorem in tech, which I think we will get to in a reasonable amount of time. I mean, I don't see any good reason why not to do this, like because here's the thing. People, if they want to still do more speculative theory building and do stuff where they leave more details aside, guess what? You can still do that. But it's just why not build up our body of knowledge in a more rigorous way? And being having these programs, like having things built in to the computer like this, I think it makes things easier, like querying known knowledge. Like I think that'll become easier. I think it'll be easier to apply things like machine learning tools to our understanding. I think it will help allow the machines to take care of just stupid little long tedious computations that don't mean anything. Like it'll make it easier for the computer to do that, so we can just keep on proving. Like I don't know, it's obvious. I don't know, it's obvious to me that this is like
I think it's coming, but to be honest, I wouldn't have expected that you actually like see this fully as a positive, because I mean, this is like a bigger conversation. It's a super interesting tangent, but I'm not sure how deep I want to go into this with you now in this recording. But there is, of course, also the question how the attitude of mathematicians will change once some of the reasoning is also taken over by the machines, right? So if we actually get there where you're always just learning with the machine, which is far ahead of you, and you feel like why should I even do this if the machine can already do this and that proof? So just to get over the learning stage as an undergrad, it will have a different vibe and feeling. And then if the machines like if you're at risk that whatever you're working on, that the machine can like scoop you because it can also get there, or somebody with a machine can get there. They will probably change the attitude. I'm really interested to see how like the attitude of like mathematicians to become a mathematician changes, because I mean I've seen on Twitter like some people say, oh, this will be another blooming area and a new blooming different area of math. But I think a lot of mathematicians are not just there to read the theorems and be excited about the math, and so this is an aspect for sure, but people also want to establish themselves, and if that actually turns out to work out, that will have an impact.
Yeah, I mean, like in terms of it taking away jobs from mathematicians or something, like I don't know, that's just like too damn bad. Like I don't know, the tractor took jobs away from teams of people like plowing the fields manually or whatever, and that's like yeah, it might suck for me because maybe I'll be part of the first like wave of mathematicians who loses their jobs to AI or something, and like yes, I'll be upset at the time, but like also I don't know, that's just the way that the world goes, and some jobs disappear because we get more efficient at performing those tasks. And the other thing is, I think like we've built machines that can move faster than humans for a very long time, and yet humans still race each other. And we've had computers that are better at playing chess than humans for a very long time, and yet humans still play chess with each other. So yes, like there may be even less jobs in the near future of like pure mathematicians. In a certain sense, like that is sad. Like maybe I won't be a professionally employed mathematician, but I'm not going to stop doing math just because the machines do it better. And I don't think in general humanity is going to stop doing math just because the machines do it.
So I'm sure you won't stop because you're already in it and you had your upbringing. But for the next,
I'm severely addicted. I'm terminally addicted to mathematics. So
but for the next generation who like feel like, oh, their contribution might be much more minuscule, it's already feels like hard. There's this strange feeling of, oh, if I would have been alive 150 years ago, it would have been easier to discover more things. That might be like a completely misinterpretation, but it feels like this at least, right? It feels like there's like a billion people. There's a lot of, there's a whole China of institutes and good people who work on things. And why should I be able to get there? And then this will be even more drastical if they are like outcompeted by billions of CPUs who also do reason, if that ever comes like people imagine.
Yeah. I mean, I suppose that's true. I'm trying to think about other examples in the past of things that like, I don't know, people would have aspired to have been, of jobs people would have aspired to have.
Yeah. Because being a mathematician is different than being a farmer, where math is more artsy in a way.
Yeah, like no one was like, oh, I can't wait to grow up to like, thrash wheat in the fields. No one was like, that wasn't like a common aspiration people had. So I guess maybe there hasn't been a time in history where some common aspiration was taken by technology. I don't know, to be honest.
Okay. But the problem is we could get sidetracked. I would also have like a lot of questions in that regard, how you feel about it. But to get more of you in this interview, actually, you didn't say your full name, I think, yet, and what you even are studying as your PhD, right?
Oh,
you're finishing, but are you actually like K-theory, cohomology? What is your PhD thesis even?
Yes, my PhD thesis is in the local Langlands program. Generally, more specifically, it's on a topic called the Piatek-Kasdan-Lustig hypothesis. So, generally speaking, what this is I want to study representations of p-adic groups. So these think like matrix groups, like SLN, GLN, SON, all of these things. But instead of C, over the complex numbers or real numbers or something, we take these matrix C's valued in the p-adic numbers. And so there's one, I could pitch this purely as a means of like, oh, I want some tool to understand like the category of representations, and how these things sort of fit together. So in particular, there's these special representations called induced representations, and I want to know there's these things called irreducible representations. Those are like the atomic bits that make up every representation. So given one of these induced representations, which are sort of generally like big in some sense, I want to know what are all the atomic bits that live in there. Okay, so that's a purely representation theoretic motivation for it. And the Kasdan-Lustig hypothesis predicts that, well, so computing these bits is sort of difficult from a direct approach, because you're dealing with like these infinite dimensional vector spaces, and there's all sorts of functional analysis going on, but there's these weird incompatible topologies. Like, it's just weird. And the Piatek-Kasdan-Lustig hypothesis says, well, actually, these numbers can be computed in terms of some geometric, some data of like singularities in over some like complex varieties. And that is also kind of sophisticated. It involves these things called perverse sheaves, and it's happening at like the level of derived categories and blah, blah, blah. And you might be like, well, God, how's that any better? I got to deal with derived categories as sheaves and some complex variety. But it turns out the punchline is, at the end of the day, a bunch of it turns out to be very computable, actually. And okay, there's still some difficulties in that, but it's like, if you can establish this abstract hypothesis, then at least there's some hope that, okay, you can do all the computations in geometry land, and there's a better, like, it's more believable to make it algorithmic. And so algorithmic in the literal sense, we're like, I have written Sage code now that does these computations. Which leverages this Kasdan-Lustig hypothesis, and these computations are just not like, you would not be able to do a similar thing purely in terms of representation theory on the Sage side. And maybe I'll just say one more thing. How does this tie into the local Langlands program? Well, the local Langlands program is about relating representations of number theoretic p-adic groups to some sort of number theoretic data. And whatever these mysterious complex varieties are that I mentioned, that I deal with these perverse sheaves living on these varieties. Those varieties are somehow like moduli spaces of this number theoretic data. Like it's like related to Galois representations. Like, you can the points in these varieties somehow give you like information about some sort of Galois representation, loosely speaking.
Yeah, I mean, from my physics background, I studied a little bit of representation theory of Lie algebras and Lie groups. That's like how I imagine it. I'm thinking of irreducible representations with stacking small matrices together, and disentangling more complicated ones. I could write down p-adic numbers, but I had never to do any proof. Like, nobody in any class ever asked me to make a proof using the p-adic numbers. I don't know if that changes things. When you say computation, you I imagine you do not mean that there's any numericals involved or any like really hard like CPU intensive computation, but it's more like you represent this algebraic object syntactically, like you do in Wolfram or Sage? And
well, so there's no numerics in the sense that it's like I'm not trying to get approximations to some value, because like at the end of the day, there's just like the numbers I want are integers. And so at the end of the day, I'm just trying to compute some integer. The computations do get CPU intensive, because I mean, so for instance, the focus of my thesis, you could look up the paper on arXiv, proof of the Piatek-Kazdan-Lustig hypothesis for GLN. Except the intro and abstract suck, so I'm rewriting that right now. But so it's for GLN, right? And basically, like roughly speaking, the computation time that it takes as n grows, the computation time is going to grow, and it grows quite a bit, to the point where like I think it caps out at GL10. Like beyond that, I mean, okay, it caps out on GL10 running CoCalc on my laptop. So definitely I can probe. I can definitely probe larger things than that, but realistically not that much larger, because it grows pretty quickly. It grows actually factorially in n, roughly.
So in a word, where does the high complexity come in? Is this like some terms which are like expanded? Are you working with like abstractly represented polynomials, and there's just too much stuff to actually do that manually, and it like there's just too much? Like I can formulate it like this: is memory an issue?
Yeah, definitely. So here's where the problem comes in. So I meant, there's all this abstract stuff about representations and varieties and whatnot, but it turns out basically once you stitch a very long string of theorems together, it turns out that these numbers I'm computing, and so you have the abstract Kazdan-Lustig hypothesis that tells you the representation theory numbers you want can actually be computed in terms of some geometry numbers. Okay, great. Now those geometry numbers, there's some other theorems by some other people that say actually those geometry numbers are related to some other geometry numbers, and then by some old theorems from like, I don't know, the 70s or 80s, like those other geometry numbers are secretly can be computed purely combinatorially. So it can be computed in terms of these Kazdan-Lustig polynomials. And that's great. So these Kazdan-Lustig polynomials, like they're sort of magical, because even in the classic case, they simultaneously count things to do with geometry, but also things to do with representation theory. But they boil down to satisfying just some basic combinatorial identities, and you can sort of build them up inductively. Now, where the computational bottleneck happens is the way that you build these Kazdan-Lustig polynomials for GLN is, so there's, I don't know if you're, well, I'm guessing you're familiar with the concept of the Weil group, since you've done some Lie theory.
I couldn't define it. I mean, I've seen all these things, but I couldn't define. There will be some X there, and
right. Yeah. So the Weil group is basically, so it's some special group that shows up as like it's a subgroup. Well, you can realize this is the normalizer of the torus mod the torus. So basically, anyways, it turns out for GLN, the Weil group is SN. It's just the permutation, the group of permutation matrices. Right. So this is some special subgroup sitting in GLN, and it has n factorial elements. And so the Kazdan-Lustig polynomials for GLN are all sort of indexed by pairs of elements of SN. Right. So these polynomials are going to really explode like at the order of n factorial as this grows. And essentially, in order to compute one of the polynomials that I need, so there's some way, I have some sort of way of there's like a representation. I'm asking about the way that some irreducible representation appears in another representation. Right? There's some way to represent that data. That data can be represented geometrically, which in turn can be like represented combinatorially. But the way that I compute how that thing is represented combinatorially is I basically have to I have to index over all elements of the symmetric group and find which ones have some certain property or not. So the thing is, in order to do like one of these computations, I have to run over all elements of a set with n factorial things. And so as n grows, this just becomes like prohibitively expensive to compute.
So, and do you know that there's definitely no like smart trick to not like, brute loop over these? Or
Well, it's I was actually talking with someone. There's someone at my university, another PhD student who's focused on like computational number theory. And I was talking to him about it, and he was making some suggestions like, he was saying something like, well, okay, yeah, I don't know. There's some technical things to get into, but basically, like, there is some hope, like, if instances of this phenomenon are like pretty rare, like in terms of like the number of elements in the symmetric group that satisfy this property, then it might actually still be feasible to try and find them all. Like there's a certain trick where you can there's some particular way to just partition up the elements of the symmetric group into certain kinds, and like once you get a hit of one of a certain kind, you can sort of go on to the next batch, and you don't need to keep searching within that list. But to be honest, I'm at this point, I'm not so sure. Like, okay, I could spend some time trying to make it work with this other strategy, but I'm like, okay, how much further does that push me? Like I'll get n a little bit larger than 10, I guess. But then pretty quickly, because I think we were talking about the case that there's some examples I'm interested in for GL16. And I think by the time you hit 16, I think we reached the conclusion that the at a rough estimate, the amount of like computing power I would need to do that is about half of the computing resources on the planet. So it's just like I'm not getting much bigger than n equals 10 anyways, right?
I mean, especially in number theory, there's these examples where if you cache things the right way and do things recursively, then you see that you can actually super speed up things. So maybe that would be the breakthrough. But if you say you're at the end of the of your PhD, you will. Does it really? Do you really want to jump back into it? Probably not. Would you say that? Like, how do you yourself estimate the value of your PhD? Like, do you regret some things about it, or what is your take there? And especially, can you also continue, because it sounds like you want to go in a more applied direction, so you might actually not come back to these particular topics, right?
Well, I have no idea. The thing is, I kind of want to make some money. It's that I want to make some money, and staying on the academic path, I don't think is like the most conducive. I mean, hey, a tenure track position, you're not getting paid chump change. You get paid
fairly, right? How many people get there, really?
Yeah, exactly. So it's like I'm still, like I'm just beginning potentially the postdoc grad. But I mean, here's the thing. Like I said, I've been applying the postdocs, so I haven't completely abandoned that path. But yeah, I am thinking more about going to industry and what I might do there. So, God, I don't know the value of my PhD. That's I don't even know, to be honest.
Well, it does not have to be value in the sense of applications for other fields or anything, but even just within. Like, are you happy, and or like, would you have? What would you have switched up? I don't want to sound it so negative. It's a negative frame question.
No, I mean but it's a tricky question, right? Because there's some like decisions I made in my life, to do my PhD that like closed as other doors. Like I think back to decisions that I had to make in order to do my PhD. And then sometimes I'm like, well, did I make the wrong choice,
What are you thinking
and
of?
I can easily imagine, like, it's very easy to imagine, like, oh, maybe I would have been happier or something if I had done this, if I'd made this other choice. But then I think back and I'm also like, yeah, but I can also easily imagine a future where, like, I had made that other choice and I'm not actually happier, and in fact maybe I'm like more miserable because, like, oh, I didn't give this other thing a shot, so, like,
Yeah.
it's very difficult to say. I mean, overall, I'd say my life is pretty good, like, I sit around all day. Like, I'm poor because I'm a grad student. I'm slightly less poor because my YouTube channel is, like, raking in some, like, very well, not huge amounts, but I'm starting to make a little bit of ad revenue. I've got some students that I tutor that have met through YouTube, so I'm making a little bit. Whatever. I'm still pretty much dirt poor as a PhD student, but I get to sit around all day thinking about math. And this semester, my duties are basically just being in charge of, like, the math help center, the tutoring center here. So I don't really have a set schedule. So, if I feel like just not leaving my room and just, like, bed rotting all day while dreaming about math, then I just do that, So, like, my life's pretty sick, actually. I can do basically whatever I want whenever I want. So, I don't know. I appreciate that.
Sounds good, actually.
Yeah.
What are the numbers at? You had said you broke 10K subscribers, and how many? Like, I have to say for the viewers, you do basically daily streams, right?
I do. I stream, like, every single day with minimal exceptions.
And how many views do you get there? And if I may ask, what does YouTube pay for that?
Oh, my streams basically make no money. Like, my typical views, I wonder, I could probably even pull it up in another tab here. Like,
we will not have video, but yeah.
Yeah, but just so, I mean, just on my end, so I can check. Total side comment. Since I know that you like history and stuff, I don't know if you know the YouTuber Fig Tree. She's an anthropologist, but just as I was pulling up YouTube, I saw that she has a new video. So
on what? I don't remember her, but
who are the Etruscans? How an ancient culture divined the will of the gods.
Well, I'm not sure if that's really my. I mean, I have some general interest, but my history interest is mostly.
It's more recent, I guess. Yeah. But
no,
by the way, I have been watching that channel that talked about the Circle of Vienna. I have been watching some of their other videos. I don't remember what the channel name is, but
yeah. So just for the viewers, I recommended to you the Congress of Vienna video, which is what the Europeans did after beating Napoleon, which I love. I love this video, especially the first part. It basically explains what the different countries are up to after Napoleon is defeated, and I think it gives. Like, it's a bit of history that I imagine Americans have literally no idea what happened there in this time. And so I know your favorite Austrian politician is surely Metternich, right?
Yes. Now it is. Yeah.
Okay, so you get some money enough that you would mention it just from
So let me just say, so I've pulled up my last 12 live streams here. So from this morning, from 40 minutes ago, I have 76 views, but the one from a day ago is 113. The largest of the 12 is 678, but that's super atypical. So a more realistic thing is the next largest one after that is from 3 days ago with 263 views. So that makes me, like, basically zero money. Like, that brings in basically $0 in ad revenue. Like, it's bringing in on the order of cents in Canadian dollars.
Okay, but so what your other videos, they have like 2,000 views or so on average.
Yeah. So that's bringing in more money for sure.
How much is that roughly?
Let me see. So I think it depends. I can actually bring up my I think I can bring up the like per video earnings. Like some of the videos where I've got like 40,000 views, those are bringing in like on the order of hundreds, I think.
Okay.
So let's see. I have like my Your Proofs Are Trash video, episode 3.
By the way, I hate the faces, to be honest.
Yeah, fair. But I think
I'm not telling you to change it because maybe it works, but
yeah,
I find this faces stupid.
No, I think it works. But yeah. So like in the last, I think this is showing me the last 28 days. So that video made $63 for me in the last 28 days. But for example,
but you cannot live from that. That's just in Vienna, I would say like 10 kebabs at max.
What's that?
10. You know what a doner kebab is? A kebab.
A what?
Kebab. Do you know what it is?
Kebab? No.
Oh, okay. This is like a Berlin Turkish heritage sandwich with meat in it, and it's
kebab. Kebab.
Yeah, exactly.
Yeah. Sorry. Yeah.
And so they are like at 7 euros now, and so $60 is not bad, but it's also just 10 snacks. So
I mean this isn't money to like quit my quit my job or like drop out of my nearly finished PhD to pursue being a YouTuber or anything. It's definitely not that kind of money. But like, I mean, in total, what does it say? In total, it says my estimated revenue for the last 28 days is $237.
Yeah, no, I mean, and maybe I expect you will be on an uptrend, especially if you have me on my channel.
yeah, of course. Yeah, I mean that's the only reason I accepted this interviews, because I knew you were gonna skyrocket me to superstardom. So.
Yeah, it's a mutual boost, I guess.
Yeah,
although I have a problem. I don't even know how to name this podcast, because now I have this scheme which I really like. So and so valued Faustian measures. I really like that, but there's no way actually to name the video in a way that makes it clear what it is about. So I can only go by maybe I do the thumbnail, the caption.
Yeah, I was about to say, maybe in the thumbnail you could just put some like random keywords and stuff.
Yeah.
And I think the title of the video is also, I mean, there's a trade-off, right? It's like you do kind of want to have it somewhat indicating like what the content is, but also just the title, the something like post Faustian measures or whatever. Like, I don't know, it's an intriguing title into itself. So like, I mean, part of me was like, I think when I clicked the first time on one of your, I mean, I think I knew about you. I knew about your channel before those interviews, but I think like in my brain, I saw the title and I think I clicked in large part just because I'm like, well, that is an intriguing title. Let me see what that's about,
Do you know Faust?
Yes. In fact, I do you know the YouTuber Angela Collier?
Yeah.
So on her second channel, she has she talks more about books and stuff. And she recently dropped like a 2 or 3 hour video talking about Faust and all the different plays and books about Faust. So actually I didn't know a ton about it until then. I just had like a vague cultural understanding. But I watched her massive video about Faust.
I have some videos actually where I rant, and I have one where I respond to her outlook in general. So
I need to check that one out. I need to check that one out.
I could link it. So I usually I make some rants and then I do them. I add them to playlists, but then I unlist them from the main thing. So I have like double as much videos as are on the main page. If you go to the playlist, you can find them. But she so I have some takes on math, YouTube, and so on and so forth. There's one, like, I really like a channel. I also listen to a lot of her videos. one thing that, again, it might work, but what I don't like is that she structures her videos in a way that they have a payoff and they have like plot twists, right? She does that where, like, there was a recent video where she talked about SETI and Dyson spheres. If you've seen this, and she you know, she there is like a twist to it, because it, in the end, the paper from who was it, Wheeler, who wrote that, like it's make it's a joke, but she doesn't reveal it, so she talks for 1.5 hours and then there's like a plot twist, and this I think that makes the videos more interesting. But coming back to my critique that I brought up when you were interviewing me, which you will actually release today, this makes them into like entertainment videos and not technical presentation videos. You know what I mean? So I'm suspicious of crafting your video in a way that has plot twists at all, because it means you're actively not revealing the information at the beginning, which is sort of contra to like an informative video, right? So it's mixing entertainment and information. This is
That's true, but you know what? So one small, a gentle pushback on that is, I would say, and I'm certainly not a professional in memorization, but people who, you know, do like memorization contests and stuff, they say that, you know, you should make a story. So even though it seems like you're trying to retain more data than just randomly memorizing a list of numbers, you know, they say you should turn it into a song or somehow like turn it into a story or something. And so one counter argument I could make to that is that, well, maybe the fact that because there's so many informational YouTube videos that I watch, and the information goes in one ear and out the other, unless like that day I run into a friend who has that common interest and I'm like, oh, hey, I was watching this interesting thing and here's something that I learned, right?
Yeah.
But I think if there is a plot twist, you could say that maybe that makes it more memorable, and at least some core nugget of information will then still be retained. But I mean, I do think there's a lot of truth in the point that
this is a fair pushback. This is a fair pushback. It's still, of course, like, you know, I agree with you. This is a good point, but it still turns the videos into something where, I mean, you have to watch it like for 1.5 hours to get to the point even. And
I think you're right. Like, it is a pushback, but I think you're right that it's rooted in entertainment more than it is in conveying information.
And similar to your you know, grimaces in your captions, just because it's kind of icky, I don't say you should not do it, because there's also arguably no point in being like you know, esoteric and nobody watches you, because it's just dry and weird and they don't understand it. So it's like
I mean, it's a tricky thing though to grapple with, because sometimes I am making these like clickbaity thumbnails and titles, and it does like feel kind of icky. Or like, I think about, you know, recently I got a Brilliant sponsorship, and I'm like making some ads for them, and you know, I'm also like, well, you know, it's not like I'm using Brilliant because like I don't actually feel like using Brilliant would make me a better mathematician or something. So it like feels kind of weird, but then I'm like, well, yeah, so I don't know. It's very hard. It's very hard, because then like in other ways I'm like, well, okay, so what, like who gives a shit? Like I do this 60-second ad, I make my money, and then I can still like, you know, I'll keep making these videos. And so I don't know, I go back and forth, and I do grapple with it. And actually in my reaction video that I posted yesterday about this recent video from DBios talking about when he dropped out of his PhD. I don't know if you know this YouTuber, that video. Oh, actually, no, I saw you commented. I saw you in the comment section there. So I know you know this video. Yeah. One of the things I talked about in my reaction video is this thing about like with music, or I gave this analogy with I gave the analogy with music, you know, when talking about math, is that like, of course, there's something beautiful in just pure self-expression, right? But like when I play music that's purely self-expression, no one hears it, because it's just me making chaotic noises like in my room on an instrument, and I never record it. I don't write down the idea. It's pure self-expression, and it comes and it goes, right?
Yeah.
And in order to share that with someone else, right? Even if you're just going to like an open mic or something, some conscious part, like some part of you is thinking about the other person in this, right? It's not just a pure form of self-expression. Like some part of you is thinking about how you're delivering this expression to someone else, right? And so there's inevitably this trade-off between the pure thing of what you want to do and thinking about how you're going to like communicate this package. And yeah, I don't know. It's weird and it's tricky, and I'm sure I'm gonna deal with this issue about like taking funding from people for things that's like, oh, do I 100% believe in this? Maybe yes, maybe no. But then it's like, wow, wouldn't it be great if I could just have a career as a like professional YouTuber and just make videos about math all day long? And so like, well, I sell my soul a little bit in order to make that happen. Like, I don't know.
Yeah, YouTube and math. There's also the question of what kind of person do you want to become, and one risk of being just a YouTuber is that you might make videos which might even be good, but then you're not actually doing like math. You want to still surround yourself probably with good mathematicians, and then you have to be an academic because you will not really find them on YouTube if we're honest, and just learning out of books.
That's true, but I think for most people that would be true, but I think at this point I'm in a unique situation, right? Because I'm at the end of my PhD. I already have publications. I already have other irons in the fire in terms of like collaboration, like other papers I'm working on with people. And so surely I could get swept up in all of this. But
you still, I think you'd still like for people to find you. How can they find you and your academic work as well on the internet? Because I noticed you didn't mention it before.
Actually, so this isn't linked in all my videos, but I think somewhere on my YouTube page is linked my Google site. I mean, if you just search Kristaps Balidis mathematics, probably I'm going to be in the first few hits. Like I have a Google site, which is I think just like Kristaps John Balidis.
Okay, Google. I just want to mention it because this will be, audio. I might link some of your stuff, like your YouTube channel for sure.
Yeah.
But for people who come across this,
or search me on Archive. I've got like 3 papers on Archive. Yeah. So,
and I want to mention again, like because we're talking about 10K, it's so funny to me that my name ends in -K and your name starts with K-.
Yes, exactly. Yeah, we're glued at the K's. We're gluing to
yes. And speaking of, so is your Langlands topic? I mean, Langlands is huge, right? So you were sitting at one corner of Langlands.
So sorry, I just want to finish this one thought about academia and stuff. So because I'm already invested in the research, I think that if I were to become a professional YouTuber, I think that would also give me the freedom. I think that would give me the freedom to just like, I think I would still keep publishing papers in my free time. And if I had the money as well, because YouTube is a very portable job, I'd probably use some of that money and freedom to go and like, go stay with a collaborator for a couple of weeks. Like I have some international collaborators, so I would use that money to go spend some time working with people, like making YouTube content, but still doing actual mathematics research.
And you think of this as an unaffiliated research?
Sorry, what do you mean by
like not being employed at the uni? You're like I like the idea. This is like very Renaissance man-ish.
Yeah.
The technical term I think previously was gentleman scientist, like 200, 300 years ago, when you had like people who were like people on their own, but they could still contribute to electrodynamics in some fashion or whatever.
Right.
And you would then be like, would you have an university email address or?
I mean, probably. I don't know, because also some people have like unofficial positions, right? Like sometimes you're a professor at one university, but then you're like a chair of something or visiting professor at another university or something, right? So I don't think it would be inconceivable. Like, of course, this is really dreaming big about everything going very well, but like in a future where I'm making a decent
I hope
money,
you get what you want there. So
yeah, like in a future where I'm making decent money off of YouTube and traveling around, probably, and if I was, still putting out, decent enough quality research papers, I probably would be able to pick up a visiting professorship here and there or something, right? Like, I'm sure those kinds of things would happen and be available to me. So, yeah.
And so, okay, yeah. But now to the K-theory thing. Is this K-theory at all? Doesn't sound like it.
Like my research, like what I do.
Like why K-theory?
Yeah. So actually, yeah, my research, well, okay, in none of my papers do I mention K. Actually, technically, I mention the K0 group, which is just the growth indeed group of an abelian category. But I don't work with higher K groups. I really don't do K theory at all. The only reason that I decided to call this channel K theory is because my name starts with a K, and K theory is some subject in mathematics. That's pretty much it. I am planning at some point to talk a bit about like topological K theory and some vector bundle stuff. Like I have this book by Max Karoubi called K theory, and like eventually I want to try and do some exposition about some of the content in there. But yeah, I really don't do K theory. It's just I was like, oh, this would be an interesting name.
I had one K-theory book borrowed from the library out of interest. I didn't get far. And of course, all the really higher and algebraic topology stuff. There are some physicists who went in that direction, but I cannot really judge how successful they are. Like there are some cool people, like I love Urs Schreiber stuff. I have followed him for like 15 years at least. But it's so exotic that I don't know if I want to disentangle myself from the rest of the world so much. That's also why lately I've been really into stochastics and these kind of things, where it's also hard and sometimes unintuitive, but at least you know that people can connect to at least the field in principle. Like probability theory is a little bit more tangible and statistics is practical. And physics is practical, but topology is soon like I know I had this insight during my PhD. I was working with a bunch of engineers, and I realized they didn't even know what topology is. Like they didn't know what the mathematical definition of a topology. Had never seen this in their courses, so it's far out.
Right. Yeah. Yeah. Yeah, it's pretty far out there stuff. And yeah, I also find this in my research, like, yeah, when I meet people and they ask what I do, like, there's even, there's areas of pure mathematics that still make sense. But the thing is, like, the Langlands program is just so, it's so like, about itself. and it's just like math for math's sake, and it's so deeply that is just very hard to, I just give people some loose thing. I'm like, oh yeah, I study like symmetries. That's just what I told people.
I read just yesterday an article, like a short essay or comment on a news page by Riel, that you had interviewed her in your channel event, right?
Yes.
It was also in relation to math automation and these lean kind of proofs. And funny enough, she mentioned Langlands, and she was like philosophizing a little bit about how bad math presentations are, and that there's a lot of burden of making this still a little bit better. She even mentioned the example. At first I was not sure if I believed her, but she said, if I wanted to explain natural transformations to another mathematician, it would take me half an hour. I'm not sure if that's true. Like, if you have an educated mathematician, do you really need half an hour, given the fact that you can easily come up with some simple vector space category examples of a natural transformation? But I guess, if you want to motivate its use, maybe.
Yeah, exactly. And I mean, it's also a question of like, explain to what level of understanding, right? Like, to explain to a level of understanding where you could, give a mathematician another random natural transformation and tell them to prove that this is a natural transformation, like on their own or something. Like, I don't know. I think a half hour is definitely a reasonable amount of time for that ask. Yeah, especially, I mean, I don't know, there's mathematicians out there like for me, concepts of isomorphism and equivalence are very natural things to consider, pun intended. But for someone who works, say, in numerical methods, where the concept of isomorphism even, is not really something that's super relevant to their work, it might
be relevant to all works, to be honest.
You think it should be relevant to all work?
Yeah.
But I mean, how, like, if I spend my entire life coming up with like numerical solutions to PDEs, why should I care about the concept of isomorphism? Like in what way would that be relevant?
Isomorphism in if you doing combinatorics, the isomorphisms are just bijections, are just permutations, so they're relevant already. Like, maybe I'm playing with words here, but isomorphisms are just narrowed down to, in this category, this is a homeomorphism and or this and that.
Sure, in combinatorics, but what about numerical solutions to PDEs?
I would think that permutations still, I mean, I'm fishing here a little bit, but
yeah,
like, if you like coming back to the algorithm stuff, there's sometimes ways to make algorithms speed up, and even if these clever theorems are not presented that algebraically, I would think, since it's like often, symmetry is important, isomorphism, symmetry of this and that. Again, depending on how much I want to bend the homomorphism concept, and
right.
But if you have, it's just, in the end, it's just a structure preserving invertible map, and that's relevant.
Yeah, okay. Yeah, and I mean, I'm not trying to say that there's no place ever for isomorphisms in like numerical solutions to PDEs, but I'm also saying that one could probably have a very long and successful career in numerical solutions to PDEs and never need to learn what the word isomorphism means, right? So I'm just saying, for those people, it might take a little bit more to both motivate and like get them to the point where they could prove something's a natural transformation, just because it's pretty foreign to their framework of mathematics.
Yeah, I mean, so here my defense, like, there's a difference between just talking about individual isomorphisms and talking about natural transformations. And if you like, a good example that I have in my mind is, if you say you have some Laplacian in some PDE, and then you say, this is the object which is at the zero, like at the origin, invariant under orthogonal transformations, and in a sense these are isomorphisms, they're metric preserving, Cartesian metric preserving transformations, and so. But again, there is this phenomenon where people stop at some level of abstraction, and interestingly, a lot of mathematicians, indeed, as she describes, do not really know the language of the other mathematicians, for better or worse.
Right.
Okay, so like, before I get to my game,
okay.
Before that, I have to get in Leo's question. So Leo, I saw in your streams, you have regular streams. Whenever I jump in, there's Leo, and then there is the Lockheed Martin guy.
Yeah.
And I just asked what should I ask them, our friend K Fury here, and he said something about a bakery. Can you explain?
Oh yeah. Well, I think actually that was just a joke. I think that was just a joke, because he just comes in and makes I don't know, off the cuff comments, and I think recently, I don't know, he just, some of his jokes, his random jokes, have just been about like bread and making bread. Okay, so I think that's part of it. But also I do have me, I've got this friend who's from Bogota in Colombia, and we sometimes talk about our backup plan. If academia doesn't work out, is we'll both go to Bogota, and he loves bread, so we're gonna open a cafe together.
I love bread.
Oh, you love bread too? Okay, great. Well, maybe you can get in on this, or when we're ready to expand, you can be in charge of our Viennese branch or something.
No, I
And
don't think I want to go into that business. I mean, unless it's super lucrative. But there is this thing where Germans and also, of course, Austrians, like the German-speaking countries, they really have a bread culture where you have like dark breads and
Right.
sour breads, which as soon as you cross the Alps down, for example, in Italy already, they don't really like they are more on the white bread side, and then it's also fun, like easy to make fun of the Americans. I'm sure there are some bakeries, but usually it's like this white.
Oh yeah, no, I mean, so it's actually interesting. The last place I was living in a house. And in the sort of the downstairs was broken up into separate suites, and one of the guys who moved in downstairs at the same time I did, so he's from Germany, just happened to be starting his postdoc in like well, he was in the math department, but he did like quantum stuff, but from a more mathematical perspective, I guess. So just by chance, I moved in with my neighbor was someone who was also in the department. And yeah, definitely he made fun of and complained about the bread and cheese that we have available here in Canada. So
when I think of American cheese, I think of this yellow thing, and I think of like Goofy. There was like this TV show, Goofy and Max.
Oh yeah.
He was like hitting the tube and it comes out.
Yeah.
So that's what I'm thinking of.
Yeah.
American cheese.
Yeah.
I said there is, you might not know this, but there is Brothorn, I think is his name, like some Marxist anarchist thinker from 150 years ago, and he wrote a book called The Conquest of Bread. I mean, this is about like food and farming and working class, blah blah blah. And I think this is the reason why there's something called bread tube, or was. I'm not sure how strong it is.
Right.
So
bread tube's more like 2016 kind of term. But I think I threw it around just the other week. I was visiting a friend who's actually he's going to be, I guess, probably after the interview that's coming out today, he'll be the next interview after that, maybe in a couple weeks. Anyways, I made some comment to him. I was like, yeah, but aren't like, because I think I was asking if he watches Angela Collier and Dr. Fatima. And he's like, oh, why do you ask? I was like, I don't know. You're just like a bread tube guy that like. So I thought. So I still use it. I still use it in conversation from time to time.
And you associate Angela Collier with bread tube as well?
Well, not exactly, but
she is very, she's very annoyed. She's very politically annoyed, and it comes out of her videos, even if she talks about math.
Yeah, exactly. I mean, there's definitely like politics in her videos, so I wouldn't strictly call her bread tube, but yeah, she's definitely more like left leaning, and then that's intertwined into her science.
It's clear who she thinks are the bad guys.
Right.
And I also I would not like this. Like this Musk and so on, these are very interesting people because they are like ultra rich people, like the richest person literally, but then still he doesn't care if he sits on a bad chair and sleeps on the floor or something like that. It's a really novel kind of thing in a way, right? So because he exercises his power, but he's not like, it doesn't come across like enjoying any luxury. And what you hear from his like Grimes and so on, that he's kind of lives like a slob still, in a sense, like overworked and on drugs, and he doesn't live in like I'm sure he has a huge house and all this kind of thing, but he's kind of he's clearly ideologically motivated and in an interesting way. It's probably not good, but I'm not on board with Angela Collier that just saying these are the bad people and everything they do is bad. And so I think sadly it's a little bit more complicated than that.
Yeah. Okay. I mean, there's a lot of stuff I don't like about Musk and what he does and what he believes, but fundamentally, I think going to space is good actually, and electric cars are good actually. So
I also don't know what I should think, because on the one hand, I think like this is a little bit dangerous, and he's clearly an egomaniac, and as are some other like tech billionaires. But on the other hand, to have things happen, you want also a little bit crazy people. And whenever you have somebody with power, people will naturally criticize them. Maybe Musk is dangerous, but maybe it's also the best we can get in that direction, right? Doing 80s politics forever is also not the solution. So, okay, I hope this bakery tour satisfies Leo. I'm sad that this was just apparently like an offhanded joke. I would have loved if there's more lore to it than.
Yeah. Well, I mean, so like I said, there is a little deeper lore that actually Leo is unaware of with the ongoing joke between me and my other friend about this bakery, and when we do like. There is a building secret lore there about things we talk about, like, oh, we'll do this like at the bakery, or like, oh, we'll do that after the bakery, or like, you know, this is a constant point of reference. So Leo actually did hit upon there's like a
I mean, just by me and you talking 5 minutes about it, it is now like now we've strengthened it a lot.
Right. I mean, now we've added to the lore the potential of expansion to Europe. So
yeah, exactly. This is a lore expansion pack. It's a little bit conflicting with you being a YouTuber because you don't want to mix topics on your channel.
Wait, do I not want to mix topics on my channel?
I do think it is quite detrimental. So my channel is basically like I do math, I do some programming, I did some distributed computing, crypto, Web3 stuff as well, and I don't think it's good because then you get viewers from one section, that people who are interested in smart contracts, my 2017, 2018 smart contract stuff when I was into that.
Yeah.
And I got a lot of subscribers. But then you switch topic and I only talk then about, at the moment I'm in my statistics phase, and these people will not necessarily stick to it. And then I have like 3,000 subscribers, but only like 200 viewers per video at the moment. And then I switched to doing a lot of rants, which is also not good. So I'm not optimizing. And also, I have also to warn you. I really hope that YouTube works out more with you, but there's always the danger that you switch to least common denominator stuff, right? So, I mean, if I see what's her name, Hossenfelder, like she's like really like if you churn out one video per day, then you pick up whatever comes down the newsreel and comment on it, and it's not helpful for keeping a higher standard, I would say, to having to give a hot take on everything. And
yeah, I mean, I think there's definitely going to be a mix of this. Again, it comes back to that question about doing a trade-off of like, okay, well, if I pump out some slop, but it means I can still make a video about like how to glue sheaves together, and that video will get only like, even if I have like 1 million subs, that video will still get like 500 views only, because it's just me doing like awful technical details about gluing sheaves. Then I don't know, like I'm willing to take on a bit of that trade-off. And to be honest, I've noticed some of this happening already, because like definitely the reaction content, right? I make these videos where I spend a long time like carefully writing out a proof to have it like on a piece of paper beside me while I'm writing, so I can make sure I explain the details like clearly and concisely. And then like, I spend hours and hours and hours on these videos that get like a couple hundred views. And then I'll make other content. Like yesterday, I made this reaction video to DBios, and it was this morning, it was already at like 2.7K, and it came out at like 6 p.m. last night. So it's like 12 hours basically. And I'm at like 3,000.
You're just I mean, I know that this is how it works, and that's I don't want to see that then you switch to that. But I also know that mixing it is also probably like might not be great for the algorithm. Like if you like go up and down, I don't know how that works.
My hope is that I will not become completely I won't become a Hossenfelder and mostly just do that. Like my hope is that I still retain some sense of like, I will make, I do think more about the algorithm and optimizing my channel, but I hope I don't become, I will try to be successful at this without becoming a total slave to it. And also to your point about like optimizing the channel, like, yeah, I will think about that a little bit, but I don't think I'm going to let myself be a total slave to that, because like this channel has evolved over time, and I think I'm going to keep letting it evolve over time as I try new stuff and different stuff. And And as my interests mathematically change, like I think I'm always going to want to be talking about the things I'm interested in, and that's probably going to shift over time. And I do think I will do more common denominator stuff, at least in the sense of like, so next semester, I'll actually be teaching a course in discrete mathematics. So I think I'll be using that fact because a lot of just basic intro to proof stuff is going to be on my mind. I'll probably be pumping out a lot more videos that's just like basic introduction to proofs and how to write a good proof and like stuff like that. So probably there will be a lot more of that content during the winter because it'll be easier for me to do that because I'll be teaching a course on it. But
it makes sense for better or worse, yes.
yeah. But like this isn't going to stop me from yapping unhingedly, like, like today's live stream, just opening up an algebraic topology book and embarrassingly like forgetting like basic graduate algebraic topology live,
about that. Like I have said this to you before, but isn't it extremely distracting to have the chat on during this? Like I cannot see you getting like any focus out of this. Because I see you reacting to almost everything at the moment.
Yeah.
If you get even more, like if the watchers, the number of watchers would double, then you would have no chance of like even answering the chat and reading. I mean, it's cozy, and I did during COVID. I did my own reading streams and stuff like that. But I think you can only do one. Either you engage with the audience and answer questions, or you actually understand the paper in front of you.
I mean, I think there's a balance. I think, definitely soon, as we've already seen evidence in some chats, the some streams, chat moves so quick that, I mean, 100% at the end of the day, yes, I'm going to make way more progress if I just ignore chat. But I think the balance I want to try and strike is maybe finding that balance of making some forward progress, but then also, I don't know, occasionally looking at chat and being more selective about what I respond to. Because you're right. Right now I respond to everything, and that is not feasible for long-term growth. But my number of views on my live streams don't seem to be growing in proportion to my subscriber count. So I don't know. But you're right. That's an issue I'll have to deal with, and I don't know. And like so this is one of those things where like, if I wanted to optimize how viewed that stream is and actually start making money off my streams, then probably I should take some time to like, as you're suggesting, just like ignore more comments. But at this point, I don't know. I just feel more like doing what I want to do on live stream, and it turns out some people want to watch that, and for the time being, that's good enough for me.
Okay, so and now we are 1 hour in, but now we will play this little game. So I already teased a little bit that I am starting to embark on a 2-month project. So I want to study Wikipedia, the math Wikipedia, the math part of Wikipedia. I already downloaded all the metadata. I have like 3 gigabytes just metadata. It's like,
oh wow.
Yeah, I have not downloaded the text yet, although this will also be possible. I don't think it's too much for just math and physics. And so this is like 50 million articles, the metadata from there, like, when were they created, editors, categories, and then also the biggest data set is like links. It's like 10 gigabytes of links, like how the articles link together. And the crazy thing is that the categories are also like several thousands of categories of because you have various subjects, World War II is a category or whatever, and even in math you have quite a few: topology, geometry, and so on and so forth. And I don't know if you know this, but do you know the math classification page? Like there's like an European Union Zentralblatt math classification, where I think this is in parts also used on Archive, when you take the article and then you classify them into what is this? Is this topology?
Right. There's like the 5-digit like alphanumeric code or something. Yeah, something, I mean, I've definitely had to like, submit, when I submit a paper, like I submit the corresponding alphanumeric codes for topics. Yeah.
And so there are like 98 over categories, and then per over category there's another 100 or more subcategories, right? So in geometry you have Lie theory, and Lie theory you have I don't know, algebraic groups, blah blah blah. So what I would do if you here is I wrote a small Python script where I took all the top categories, this 98 categories, and I shuffled them and paired them up, and we will basically do like an elimination game. I will tell you 2 of the categories, and you tell me which one is better and why.
Okay.
Yeah, so,
okay.
and,
I love it.
Yeah, and you know what? I don't know. Probably I didn't do like the calculation. This probably might take a while. So you best say like 1-2 sentences about why. Or maybe it's obvious to you what category is better and whatnot. Okay. So I have this Python script in front of me, and I've shuffled the numbers, and so I will go through them, and whenever you say what is eliminated, I will remove it from the list. There are 98, and we're going to have this halving round. Okay. So our first pair is general algebraic systems, and if you want, I can look up what it actually means. This is like one of the categories here. There are some other algebraic. There's like algebraic geometry will be in a separate category or so. But this is paired up with manifolds and cell complexes.
Well, since I don't even know what the first one is exactly, then the manifolds and cell complexes. Then it's definitely better because I know what it is.
I can look it up for you.
No, that's fine. We have a long list to get through, so I'll be decisive on this because Lord knows there's going to be some that I'm going to be indecisive on anyways. So.
Yeah, I know. I just looking in the subcategories. There's like 100. They get splits up in 100 things, but these are all fairly generic. So there's lattices and various varieties in there, and infinity algebras. So you're cutting out a lot of math now. But I mean, manifolds are nice, so that's fair.
Yeah.
Okay, so what I have to do is on my side, I have to delete this field and just keep on the other ones because they will be, randomly repaired later. The next contestants are. Oh, damn it! I now see that. I see. Okay, not all numbers exist actually. I just realized now that it's a list from 0 to 97, but. I think they reordered it through the years, but this is decades old, so I cannot use this. So then we do. Okay, let me see. Number theory is coming up against probability theory and stochastic processes.
Number theory, 100%.
Okay, but justify kicking out. Like this hurts me a little bit because not that I dislike number theory, but it's a little bit less tangible for me and less, as much.
Yeah. I don't know. I love number theory. Number theory is a huge, vast field that ties into so many interesting things, including my research. I love number theory. I don't know what to say. And like, I kind of wish in some part of me wishes I had done like stochastic something probability something and it had become like a rich quant. But I've tried studying some stochastic calculus and I just don't love it as much as number theory.
Yeah, I mean, I don't know if there's a guarantee that you become a rich quant. I'm talking to a guy who does convex optimization, and he seems very solid, but I don't get the vibe of him that he, is in finance. But I think this is also a gamble. Like I think this kind of fields lure people in, but then as I talked with you in the other direction interview, I think in practice these things look a little bit different than what you imagine. Even if you're a quant, maybe you have watched. The Big Short, but I don't think usually the math is all that fancy in reality.
Right.
Okay, so the next battle is statistics versus commutative algebra.
Commutative algebra.
Who could have seen that comment?
Actually, this is maybe a little tough because, I have a lot of interest in like actually maybe this is tougher like in terms of what I actually do. And like if you put me in a room and you're like, hey, Kristaps, I want you to come out of this room and tell me either some things. Here's a stats book and here's a commutative algebra, and I want you to like do some problems for them or tell me something interesting that you learned. 100% I'm picking the commutative algebra book. No shot. Like in terms of what I would actually want to spend my time doing, 100% it's commutative algebra, no competition. However, I mean, statistics matter so much more for the actual world, for knowing things about the world, from physics to sociology. And I'm interested in things like sports science and nutritional science, and I get these little tidbits of information from YouTubers that talk about this stuff, and then sometimes they point to papers and I like go read those papers, and then you go look at you look at the stats and the methodology and the p-value, and it's like, oh, these are all like super important things, and like meta studies, blah blah blah, and like stats is like integral to all of this, and it's integral to AI, and like, so yeah, I don't know. What it depends on how we interpret better in this case. I mean,
we have fixed your choice because I've already deleted this ones, but
okay.
I mean, this is kind of the thing I would like to get out of you here. This sort
Yeah.
of evaluation. I know, like these two subjects are both kind of important, but it's also interesting that they are fairly different, right? If I think of commutative algebra, I think of very different things than statistics. And also, I have, as I told you, I've delved more into statistics lately, and there's so much theory that I did not know exists. You can take things from a information theoretic angle and a more computational angle and the higher dimensional stuff. And I am deeper into it now for a few months, and it says so much. It's actually cool. It's actually really cool. Doesn't feel like number theory at all. But there's also like hard proofs and theorems where you think, oh, this is so abstract. Is this really necessary? But it's cool.
Yeah.
And
let me put it this way. If you gave me as a singular person the choice of I have to do exactly one of these things for the rest of my life, then it's commutative algebra. If you gave this, if you then instead gave me the choice, Kristaps, you have to decide what humanity can only do one of these two things for the rest of your life, commutative algebra or statistics, then I would choose statistics.
Yeah, this is a very different questions, but then I think many people would weigh these against each other like this. Okay, so let's go on. History and biography. This is also, it's not a math subject strictly, but it's matched up with calculus of variations and optimal control optimization.
Again, for myself, definitely history. I'm interested in history. I like stories. I've got some math history textbooks. I've got some autobiographies, and
can you actually recommend in this direction? History textbooks and so on. What do you like?
I don't know if I have any great recommendations. Like, what are the books I have? Boyer. It's not on my shelf in my room. It's on one of my shelves in the living room on display. So I don't know the author. I think one of the authors is Boyer. Like, it's kind of superficial, and it sort of ends before, like, it ends at the late 1800s, I think. So it's maybe not like ideal. I've got another textbook that I used from class. I don't know if I'd recommend it. Definitely the book. Yeah, I think it's Boyer or something. I mean, but I would say it's still good. It's a good overview. Like, it's sort of shallow, but it really starts off from like the dawnings of the earliest evidence of math that we have to the modern day. And it's a pretty thick book. Like, it's definitely I think well over 1,000 pages. So there's a lot in there. So not a bad book for beginners, actually, I guess, to get started. Not that I'd say I'm advanced in my math history. There's some books like, I've got, for instance, Paul Halmosh's Automathography, as he calls it. And what's interesting about that is like reading about there's his time in grad school, like there's certain theorems and stuff that he's talking about. I don't remember what they were, but they're theorems that are like in analysis, and these are things that like you would learn now as like in a typical like graduate functional analysis course. It's like you'd be maybe given this, either the proof is explained in class or you'd be given this as an exercise, right? But he's basically talking about this theory. He's talking about the papers as they're coming out, as the theories like being developed, and it's like so cool to go back and like, I don't know, hear about it from this perspective. It's like such just a standard thing that you learn in school these days. And like, he's talking about when it was cutting edge stuff. So, I recommend that. There's this book, like I have this book, Mathematical Apocrypha. It's more just sort of like tidbits and quotes and actual math history. Oh, actually, I have this one very cool book. I never would have like thought to have looked for this or ordered it online or anything. But I just found it randomly in a bookstore one day. It's called the Fermat Diaries.
Okay.
And basically what it is, it's a recounting, it's a short book. It's a recounting of the story of the proof of Fermat's last theorem. And it's full of a bunch of pictures. But here's what's really cool is that it's largely comprised of emails from mathematicians to each other. Okay. So because it's this interesting snapshot of time when we had like the early internet, we had emails, but there was nothing like Discord or YouTube or any of these other ways of disseminating information. So it's really cool that there's these emails that are saved from back then of different mathematicians. Like, some of them are from Fermat, but some of them are like other mathematicians, like communicating. Or sorry, not Fermat. Wiles. I mean Wiles. Of course, it's not so. But yeah, some of these mathematicians being like, oh yeah, I was at this seminar, I was at this crazy lecture today. And, because back then it's not like he was putting this lecture on YouTube or something. And, so it's just, it's really, really fascinating from that perspective. Okay, that's very narrow. This maybe if you're generally interested in math history, that's not.
So I actually have 3 comments here. Firstly, there is the Foundations reading list online, which is kind of funny. So this is like also like logic and foundations. Certain people, there's a lot of fights over there, and everything from 20 years is preserved. This is very fun to read. You can find it online, Foundations reading list. Oh. It's basically an email list, and some of those email servers exist here and there. Then, do you know Halmos photo book?
Photo book?
Yeah, Halmos was like a hobby photographer, and there's like a photo book where he has from 30 years of conferences, all the pictures of mathematicians on conferences that he went to.
Oh no, I don't know.
It's also amazing.
Oh, interesting.
Yes, and maybe if you find it, you can maybe find it online if you search long enough.
Yeah.
It's really nice. It's just photos of, you see Kleene and you see, all the set theories, and you just see pictures of them on and he makes a comment on everybody. Oh, this is good, blah, blah, blah. Or maybe good list was too early, but there's like 200, 300 mathematicians in there. And lastly, I have a good recommendation that I read it a decade ago on history. It's called by Corey. I think it was his like PhD thesis or so, but it's like basically history book, but also like investigation. And it's called Modern Algebra and the Rise of Mathematical Structure. And it details exactly how, like it starts around with Hilbert and Noether, when it really starts with Galois, but then shortly after, like how the main focus is on how algebra kind of transformed, and where you have these things ending up in textbooks, and he goes through these 100-year-old textbooks and see how from generation to generation algebra is presented differently, like axiomatically or not, and these kind of things. And it's a really good book, and I think it ends somewhere after category theory. Modern Algebra. It's called like that because Modern Algebra was one of these influential algebra textbooks by a guy called Werden. There's some, you might have seen this in some Werden theorems. There's some algebra stuff around the time of quantum mechanics. I actually have in the playlists, I have some book reviews of some history books on quantum mechanics and a little bit of Schur and these kind of people. Also fascinating stuff. Okay, but let's continue with the the battle to death here. We have field theory and polynomials versus global analysis on manifolds.
Field theory and polynomials.
You're such an algebra field guy.
Yeah. I mean, I do like some differential geometry, a little bit of functional analysis, but like 100%, I'm into fields and polynomials and Galois theory and stuff like that.
Okay, the poor geometrists are going to get killed off here. So we have geometry. Geometry. Okay, I think I saw this. This is not a good competition here. Geometry versus algebraic geometry.
Yeah, it's kind of weird though, because doesn't geometry subsume algebraic geometry?
Yeah, that's why I'm laughing. But these are the categories they have. So I don't know.
Well, then I'm just gonna say geometry then.
Okay, yeah. You're very logical minded, I say.
Yeah.
Okay. Then mathematical logic and foundations versus convex and discrete geometry.
Which one do you think I'm gonna pick?
Yeah, this is good. I mean, I would think you will say you are. I mean, I don't know actually, but I think you have an interest a little bit in logic and foundations, right? So you have like a tingling.
Yeah. No, I would definitely pick that. I mean, there is some stuff about discrete geometry I find interesting. Like I think finite projective planes are really cool, and there's some like very I like graph theory, and there's some very geometric graphs. But yeah, to be honest, again, like if I had to be on a desert island and study one thing for the rest of my life, it would probably be logic and foundations.
That would be the one thing you studied for the rest of your life, or is it just
between the two?
Okay, makes sense.
Yeah.
Okay. I have to think here a little bit because, as I said, some of the numbers are missing, and I have to check if all of them exist here. Yeah. Okay. Combinatorics versus general topology.
That's maybe a little trickier. Because I do have combinatorics in my heart. Like my first publication is from an undergrad research project I did in graph theory, and nice. One of my favorite open problems is a problem in graph theory. To be honest,
what is that?
It's the missing Moore graph problem. Yeah,
I think I've heard of that.
Yeah, basically it asks to find all graphs which are k regular, have k squared plus 1 vertices, have diameter 2 and girth 5. And in 1960, Hoffman and Singleton showed that the only possible values of k are 2, 3, 7, and 57. For 2, 3, and 7, those graphs are known to exist, and they're unique up to isomorphism. They're respectively the 5-cycle, the Peterson graph, and the Hoffman-Singleton graph.
Or you noticed in some detail this problem.
Oh yes. I'm very. I know a lot about this problem. I'm very obsessed with it. Have been for a long time. And so the missing Moore graph is the 57 regular one. So we still don't know whether it exists or not. It's the only remaining possibility, but we don't know if it's actually realized.
Yeah.
Okay, there's a lot more I could say about it. So yeah, but it's hard because general topology like makes a lot of the more specific kind of topology things I'm interested in even possible in the first place. And it's also like very mysterious, and it's maybe like, oh God, I don't know. Yeah. God, I don't know, because if I say no to combinatorics, does that mean I'm saying no to the Moore graph problem? I don't think I could ever do that. But can I say no to the vast open seas of general topology?
Make a choice, bro.
I'm a very indecisive person. This is why I was like, no, don't, I'm going to act quick on these other ones that are very clear to me. God, let's just say general topology, and it'll probably keep me up at night. I'll probably regret.
Okay, so you kill off combinatorics to get that right.
Sorry?
So you're killing off combinatorics.
I guess.
It
hurts me.
Hard. Yeah, I noticed.
Yeah,
I like
hurts
that.
me to
I like
do
that
it.
it hurts you, to be honest.
Yeah. You're
Okay,
sick. You're a sick man.
Maybe.